Okay, so I'm just starting uh, a new playlist or a new sub channel here in on my channel, and I will this is just basically discussion about computer science related topics, anything related to computer science, especially like web development, data structures, algorithms, problem solving, and various other topics, maybe operating systems, DBMS, anything. So basically, I'm trying to find a community or trying to be part of a community that actively participates or actively does problem solving on various platforms like LeetCode, CodeSafe, etc. And so this is that is why I'm basically starting a channel based on based on like problem solving. Okay, so I'm just trying to test my setup, my video setup, video, audio, everything, and my setup in this video. This is not going to be a very long video. It's going to be, this is not going to be a very long video. It's going to be a rather short one, because I'm just trying to test my setup here. Okay, so we'll look into a problem. We'll look into a problem called to sum in this video, and I'm just going to discuss the optimized approach. I'm not sure, maybe there's even there might be a more optimized solution than this. I'm not sure, but the approach that I'm going to talk about or discuss in this video is it will take n log n complexity, big O of n log n complexity, and this approach is going to involve basically of two things. First of all, we'll have to let's just look at the problem statement first. So we are given an array of integers, nums, and an integer target, and we just have to return the indices, or we just have to return two such numbers in the array or in the given array, such that they add up to the target. Okay, so let's just take this example array in as the first example. Okay, so let's just take this, and the target is 9. Okay, so this approach is going to basically contain two steps. It is basically two steps. The first step is sort the input array, and then after that the second step is apply a two-pointer approach. Okay, so all right, so let's just imagine, so now let's imagine that we already have our we have already sorted the given input vector or the given input array, and then we have the sorted array. All right, so in this test case here, or in this example here, the given array is already sorted. So sorting the given input array will basically do nothing. So this is our input array, this is the sorted, this is after sorting, applying sorting. Okay, so let's so we are done with the first step. We have sorted the given input array, and now we'll go ahead to the second step, right? So what the second step basically says is, we'll have two pointers, one named low and the other named high. Okay, and what we are going to do is basically we are going to initialize the low pointer to the first element of the array. So this will be our low, and we are going to initialize the high pointer to the last element of the array. So this is going to be our high. All right, so the basic intuition, and obviously array of low, that is this area of low, is going to be like smaller than area of high, obviously, because this array is sorted, right? Okay, so now the intuition here is, if at any given point of time in this two pointer approach or in this two pointer algorithm, if array of low plus array of high, if this is equals to the given target, which in this case the given target is 9, okay, so if at any point of time in this algorithm, if this condition becomes true, that then it means that we have found two such elements in the array such that they add up to the target, and so basically we have found our answer. We can return the values of low and high. We can return the values of low and high. But here obviously this is not the case. Here low plus high is greater than the target, because area of low is 2, area of high is 15, so this adds up to 17, which is obviously greater than the target, which is 9. So now we know that the array is sorted, right? And array of low plus array of high gives us a sum which is greater than the target. So in this case, what do we need to do basically? So obviously we need to lower our sum, right? We need to lower our sum of area of low plus area of high, right? We need to lower the sum. So the sum of area of low plus area of high is 17. Let's take let's keep it as 17. This is 17, which is greater than the target, which is 9. So we need to lower this value. We need to lower the value of 17, so that it gets closer to the target, right? We need to get more closer to the target. And how do we get closer to the target? By reducing the value of area of low plus area of high, right? And how do we reduce the sum of area of low and area of high? How do we reduce it? It's simple, right? We reduce it by reducing, or by left shifting the high pointer. We shift the high pointer from here to here, right? And obviously we cannot left shift the low pointer, obviously, because the low pointer is already at its the low pointer is already pointing to the smallest element in the array, which is this 2. So if we like left shift the low pointer, then we'll go out of bounds of the array. So obviously we cannot lower the low pointer. So if we need to lower the sum of area of low and area of high, area of low plus area of high, all we have to do is just left shift the high pointer, right? So okay, so we have left shifted the high pointer from here to here, and so the indices of the elements will be 0, 1, 2, 3. Okay, so now what is the sum of area of low plus area of high? It is nothing but 2 plus 11, which is equals to 13, which is obviously we have gotten closer to the target sum. Earlier the difference or the distance between area of low and area of high and target was the distance was 8, right? Because 17 minus 9 was 8, is 8. Earlier the distance was 8, and now the distance is only 4. So we are obviously closer to the target sum, but still we are not we are not at our answer. Basically we did not find our answer yet. So what do we need to do? We need to lower the value of area of low plus area of high further. We need to lower this value further. So how do you lower the value? You just left shift the high pointer, right? You just left shift the high pointer. So now area of high will be 7. So the sum will become 9. And now you see that this is equal to the target, which is 9. And that means that we have got our answer. So our answer will be answer will be these two elements, this 2 and this 7, right? So our answer will, and the indices of these two elements are nothing but 0 and 1, right? So our answer in this case is 0 and 1. Now what if let's say the target would have been, let's say instead of the target being 9, the target would have been, let's say 25, let's just say, okay? And let's just start from the beginning. Okay, so the low is here and the high is here. Okay, so if the target is 25, that means here area of low plus area of high is 2 plus 15 is equal to 17. 2 plus 15 is equal to 17. So definitely this is strictly smaller than our target, which is 25. So we need to increment this value. We need to increase this value, right? Increase the value of area of low plus area of high. And how do we increase the value of area of low plus area of high? We just have to right shift this low pointer, right? Because if you right shift this low pointer, we are going to get a larger value than what the low pointer is pointing to at currently, right? So the low pointer is pointing to this 2. At this point of time it is pointing to this 2. So if we right shift the left pointer, we know that the element on the right hand side of this 2, all the elements on the right hand side of the current element, on the right hand side of the current element is going to be greater than the current element. So which means if you right shift the low pointer, then array of low is going to increase, and as a result the entire sum of area of low plus area of high is going to increase, and thus we will get closer to this required target, which is 25, right? Now one question arises, why can't we right shift the high pointer and get a even larger value for this for this high for area of high? Well, because if you right shift this high pointer, you are going to go out of the bounds of the array, right? Okay, so we will left shift the low pointer. So the low pointer is here right now. So now area of low is 7, area of high is 15, and the sum becomes 22, and it is still smaller than the target, but as you can see right now, we have gotten closer to the target sum, required target sum. We have gotten, earlier the difference between 25 and 17 was 8. Here the difference was 8. Now the difference is just 3. 25 minus 3 is 3. So we are getting closer to the target, right? But we are still but area of low plus area of high is still smaller than the target. So what do? We again left shift the low pointer, because obviously we can't right shift the high pointer because we'll go out of the bounds of the array. So we right shift the low pointer so that we can get an even higher value for area of low. So if we right shift the low pointer, we are going to get an even higher value or even larger value for this area of low. So this is area of low, okay, right? So we are going to get an even larger value. Instead of this 7, we are going to get 11, and this 15 will remain as it is, right? So now the sum will be 26, right? And now what happened is area of low plus area of high has become greater than 25, So now if it is greater than 25, we need to lower the sum. And how do you lower the sum? By left shifting the high pointer, right? By left shifting the high pointer. So you left shift the high pointer. So the high pointer will be here. And now the high pointer and the low pointer are basically pointing to the same element. So let's check this. 11 plus 11, so this is 22, which is still smaller than 25, so we need to now increase the sum. And how do you increase the sum? By right shifting the left pointer. Right shift the left pointer, and now here the condition gets violated, because now low has become greater than high. So now the condition is violated. So it means when this condition gets violated, and we still and we have still not we still did not get our answer, it means that we have checked the entire array. And there was no two elements in the array such that they add up to the given target. So which means we need to return, I guess, -1 in this case. We just so it just means that there is no answer, there are no two elements such that they add up to the target, right? So this was the basic intuition, and I'm going to like end the video right now. I'm not going to code this solution up. Maybe in a future video I'll code the solution up, because this is just a test video. This was just a test video, so I'm just going to upload it as it is. And yeah, I'll meet you in the next video. All right, so bye.